Hey everyone, I'm Asha, and today I'm going to be talking about green computing and sustainable practices in IT. Right. So all of us use like various electronic devices, like mobile phones, computers, even smartwatches, and various cloud services as well, like Google Cloud. But we never think about the impact that these services and devices are having on our environment. So that is what I'm going to be talking about today. And I'm going to tell you about how it's affecting our environment and what we as individuals can do to make it better. Now, let's talk about what is green computing, right? So, green computing or sustainable computing is using computer systems and resources in a way which is efficient and good for the environment. So, this begins all the way from the designing, development, the way we use and dispose these systems, right? So, what we're trying to do over here is we're trying to increase efficiency and resource optimization while trying to reduce environmental impact and e-waste. So a lot of you guys might think, right? Why does this matter or why should I even care? So let me tell you something. Data centers alone consume around 460 terawatt hours of energy every year, which is around 2% of the world's energy consumption, right? And manufacturing a single laptop can produce up to 300 kilograms of CO2 emissions. Right? Last year alone, we produced around 62 million tons of e-waste. To give you some comparison, that's almost equivalent to the weight of 10 million fully grown elephants, considering each one of them weighs around 6 tons, right? We use a lot of rare earth metals which are non-renewable for the manufacturing of these electronic devices. And the mining of these materials causes further pollutions. So now let's talk about some of the technical causes of high carbon footprint, right? So networks alone use around 300 terawatt hours of energy every year, right? So one of the major reasons for this is our transition from 4G to 5G. And 5G alone consumes around three times more energy as compared to 4G due to the high data rates, right? All of us use cloud, but what if I told you around 60% of the data on cloud is redundant data, right? And storing a single GB of data costs around 1 kilowatt per hour annually. Many places use old servers which consume around 200 to 300 watts of energy as compared to the newer ones which consume around 50 to 100 watts due to the higher transition costs. And to make things worse, only 17% of the electronic devices are actually recycled. So what are some of the energy efficient hardware solutions, right? So we can use low power processors like the Apple's ARM based M series processors, which consume around 15 to 30 watts as compared to the traditional 65 to 125 watt. We can use Energy Star certified servers, which consume around 100 watts as compared to its older counterparts, which use around 200 to 300 watts, right? We can use SDDs instead of HDDs as they reduce power consumption by almost half. We can use advanced cooling systems like the liquid cooling system used by Google DeepMind, which has reduced their energy consumption by around 40%. So this is a visual comparison of the energy consumption of efficient hardware solutions and the traditional ones. So what are some of the energy efficient software solutions we can use, right? So we can write code which has like less time and space complexity. For example, we can use binary search instead of linear search, which reduces the CPU cycles by around 90%. We can use software like the Linux's CPU frequency, which lowers the CPU frequency by around 20 to 50% for low computational tasks. We can cache the frequently accessed data, which reduces the network energy usage by around 30%. We can implement deep sleep mode for applications and reduce the number of applications which run in the background. So here's how much each of these software optimization techniques can affect energy consumption. So now let's talk about how we can integrate renewable energy with IT. We can use solar and wind farms to power these huge data centers. Companies like Apple and Facebook have already implemented this and have reduced their emissions by quite a lot. We can use AI to schedule and optimize tasks when renewable energy is available at its peak. We can store energy in smart grids and use renewable energy efficiently. Now let's talk about reduce, reuse, and recycle of e-waste. Right? We can design modular, upgradable hardware to extend the life of these devices and minimize the need for replacement. Right? We can provide longer software updates to keep these devices more relevant. We can refurbish old devices. We can provide discounts to users who recycle their old devices, and we can use recyclable and biodegradable materials in the manufacturing of these new devices to reduce the environmental impact. So what are some of the benefits of green computing, right? Green computing reduces the overall energy consumption of data centers and hence lowering their operational costs by quite a bit. It decreases the carbon emissions of data centers, which is crucial for mitigating climate change. It minimizes e-waste through recycling and modular design and hence reducing landfill pollution. It enhances resource efficiency by using sustainable materials and renewable energy. It improves corporate sustainability by boosting brand image and regulatory compliance. So, what are some of the challenges we face, right? So, the initial setup cost for renewable energy infrastructure is pretty high, which limits its adoption, right? The global infrastructure for e waste recycling is very limited. India is the third largest producer of e waste and yet only recycles about one third of that e waste. And there isn't much knowledge about how to properly dispose e waste. Legacy systems and softwares are often not compatible with the new energy efficient technologies. Balancing performance needs along with energy saving measures is often quite difficult. So what does the future look like, right? So we can use renewable energy to power more sustainable computing infrastructure. We can use AI to schedule and optimize tasks for when renewable energy is available at its peak in data centers. We can make advancements in modular design of hardware so that we can reduce e-waste and extend the lifespan of devices rather than replacing them every now and then. We can have stricter global regulations for emissions, which can drive innovation in green computing. We can use quantum computing, which is way more efficient and minimizes energy use. So by now, all of you know that green computing is not just a trend, it's a necessity, and all of us need to make small steps towards it. So let's build a sustainable future through conscious computing. And again, thanks for watching.